All right, so let's talk about a linear search algorithm. Now, I have in front of me a sorted data set. You don't need a sorted data set for a linear search, but for this first example, we'll use a sorted data set. So what a linear search does, or a standard kind of search does, is it'll take the thing you're looking for, in this case a 4, and it'll just simply compare it to each item in the list until it finds it. So I found it here, I can return that, hey, the thing was at the second index, I have my answer. Or I could look through this entire list and not find it. So say 4 was missing, I could look through the entire list. When I've gotten to the end, if I haven't found it, I would return maybe an index of -1 or false to indicate that it wasn't found. So a linear search, again, does not need to use ordered cards. So let's scramble these up a little bit. All right. And now I don't have any discernible order to my cards. And I'm going to compare to the first, second, third, fourth, find my card. I can return this index. If the card was not present and I go and look, I have to go through the whole list just to find out it's not there. Now, the downside of linear search algorithms is that even if your data is in sorted order, so let's suppose we're back to this, it should be pretty apparent that something's not there pretty early on. So for example, if I'm looking for a 4 and I know my data is sorted, once I get to a number that's bigger than 4, I should be able to leave. So you can enhance the linear search algorithm by adding a caveat like that if the data is already sorted. The problem is it takes effort and computational cycles to sort the data. So let's take a look at some sorting algorithms to see what's involved in actually getting this data set in order to begin with.